Good morning, good afternoon, and good evening, depending on what part of the world you're joining us from. And on this webcast, we have people joining from all around the world in every time zone there is. So we're all excited to have you joining us. And if you're listening to this in a recorded session after the fact, again, from whatever time zone you're in, thank you for joining us. My name is Tim Conway. I'm with the SANS Institute. I'm the curriculum lead over the industrial control systems curriculum and kind of our courseware and our certifications and all the good work we're doing there. My main goal for this webcast is to turn it over to the other three gentlemen that you see on the screen currently and let them kind of work through all of their slides and all the great information that they have prepared and are ready to deliver for you. The first thing that I get to do that I'm excited to do is to introduce each one of them so they don't have to be shy in their own introduction. So I'm going to talk to you a little bit about where these speakers come from and their backgrounds and kind of their areas of focus in NERC CIP. I'm going to start with Rustin Johnson, who is the Global Energy Industry Advisor at Splunk, where he oversees the strategy and growth for the energy and utility areas throughout Splunk. As many of you know who are listening, Splunk helps a number of entities leverage their data to improve the security and resilience of their IT and OT environments specifically, as well as satisfy key requirements and necessary capabilities within their cybersecurity programs. Rustin has a broad range of experience in the energy industry spanning over 25 years. If you've paid attention to any of our Ctrl+Alt+Comply series, you may have noticed that in every session we have, oftentimes we have a set of speakers that is approaching decades and decades and decades of experience in kind of this space, and this session is no different. Rustin has held roles in engineering services, DevOps, business development, working closely with Fortune 500 companies, and prior to joining Splunk, Rustin held positions focusing on demand response, energy management systems, SCADA, industrial control systems, smart metering, utility bill management, energy procurement, compliance, and sustainability reporting. So again, thank you for joining us, Rustin. Our next presenter, Robin Berthier, is the co-founder and CEO of Network Perception. So for those of you that have been working in CIP for any period of time, this is an organization that you should be very, very familiar with. He has over 15 years of experience in the design and development of network security technologies. He was a part of the University of Illinois research team that originally developed the technology that drives the network perception platform. He received his PhD in the field of cybersecurity from the University of Maryland, College Park before joining the Information Trust Institute, ITI, at the University of Illinois, Urbana-Champaign as a research scientist. And again, from my utility experience and from others who are joining, if you were in the Midwest and you were working for electric utilities during a long period of time, there was very, very close relationships with all the research projects that were going on at University of Illinois, and Robin was a part of many of those. So again, thank you, Robin, for joining us. I appreciate it. The last speaker that I will introduce, Mr. Thomas Peterson, cybersecurity leader with GE Vernova, the electrification software side. Thomas has 25 plus years. So again, two of our presenters have over 25 years of experience in this space. Years of experience in cybersecurity, kind of high-tech defense, aviation, healthcare, banking, and energy, from startups to Fortune 500s, Fortune 100s in some of his experience areas. Thomas has been advising and advocating for leaning into the terms you'll hear around assumed breach and contested territory and zero trust mindsets. Thomas is currently the vice chair of the NERC CIP committee, which on our next slide, we will expand a little bit on what that means if you've never heard that term. And leading the new technology enablement, DER, aggregator, security guidelines, and efforts for advancing the AI and ML security white papers. Thomas has advised utilities across North America, Canada, US on critical infrastructure protection strategies throughout his 25 years of work in this space. So again, Thomas, thank you very much. This has been a challenge for me as I'm looking to get out of the way as fast as possible, but to really cover the depth of experience of all the speakers, I find myself 5 minutes into the presentation before I can turn it over to you. There is one thing that I would like to cover before I turn my own mic off and let our speakers take over. And it really is this discussion on the Cloud Technology Advisory Group. If you did not attend our first webinar, where we described what this group was and how we've all come together, I will try to summarize this quickly again because I know we have a lot of material to cover. In the first webinar, we dive deep into where this came from, what it does, what it is, and what it isn't, and really tried to highlight that this type of work is something that utilities and asset owners and operators across North America, this is something that we have a history in and a history of doing, and it's collaboration across our peers, across our vendors, across application providers, system integrators, and really trying to do good for all. As we all know, we work in the communities that we serve. We're not only employees at utilities or entities, but we are also customers. So when we see a challenge or a problem, we generally will lean in and work together to address it. This is one of those areas. This group is what you would say is a coalition of the willing. So it is a group of people that are looking at the current NERC CIP standards and technologies like cloud and the areas of concern that we are trying to get ahead of and identify so that we can have them addressed and we can continue to move forward using innovative technologies like cloud. So this isn't a presentation where we are highlighting specifically a software provider. These are members of the CTAG group that have been working on this for some time. And because we know there's different perspectives and things that need to be addressed, from asset owners and operators to regulators to consultants and contractors, application service providers and cloud service providers, we have some that have sort of raised their hands and said, I'd be willing to talk on that. And again, this is for a community effort for the good of all. This is modeled after the version 5 transition team. There are members from NERC, from the regions, from SANS, from the electric industry, service providers, and others. They are all here to support this effort. It is a 6-webinar series, and I have a feeling just based on questions we received, there will be more to come. Again, there is a group that exists, and that group, we are doing what we can from members of CTAG to help support any of the groups or any of the drafting teams that are working really hard on this effort of NERC CIP and cloud. One of those groups, the Security Integration and Technology Enablement Subcommittee, also known as CITES. As I had mentioned in his intro, one of our speakers today, Thomas Peterson, is the vice chair of that CITES subgroup. With that, I am going to ask Rustin to verify his camera and microphone are good, and then I'm going to mute myself and turn this over to you, sir.
Perfect. Thanks, Tim. Really excited to be here, and I will do my best to cover all things Splunk, SIP, and cloud in 15 minutes. But at least wanted to provide our perspective and share what utility customers are doing in terms of architecting and really how they're managing SIP compliance specific to Splunk. So next slide. I would imagine most of you, or at least have heard of Splunk or familiar with Splunk. Cybersecurity is one of the first things that comes to mind. But really, if I were to boil it down to its essence, Splunk is a software platform that helps security, IT, and DevOps teams really improve the resilience of their business system. So effectively what we do is we ingest data from a number of different tools and data sources. We're really data source agnostic, and things like logs, metrics, traces, all the digital exhaust that you get from the machines in your IT and OT environment, and we allow you to search and analyze that data in real time and at massive scale. So specific to cybersecurity, we have a suite of cybersecurity tools that are part of that. We are a SIM, so for security information and event management. And over the years, we've grown as a 20-year-old company, now owned by Cisco. If you guys missed that announcement, we've grown from on-prem environments into cloud and multi-cloud. And just wanted to share some perspective today on what's really driving cloud adoption, why there's a need for it in the industry. Some of the things where all this comes together in the context of compliance is just the cost of downtime, which I know we all know resilience is mission critical. But we did a study and found that most larger organizations lose up to $200 million a year in costs from downtime. So one example, we've got a customer, a large utility in the Northeast that their outage management system cratered under the demand during a large storm event. So their customers were literally and figuratively in the dark for several days with no way to report outages, no way to get estimated restoration times. And as a result, they saw over $100 million in regulatory fines and customer paybacks. And fortunately today they're in a much better place. They're using Splunk to monitor their infrastructure and their applications across legacy apps and cloud native apps, and do that in real time to help with troubleshooting and restoration of any issues. But of course, what we're mostly concerned with here in this audience today is just the growing threat and cyber risk. And I don't think I have to tell anyone what that's like. We look at things like China pre-positioning with Volt Typhoon. We look at the use of AI and more sophisticated attacks now focusing more and more on OT environments as well. So that's obviously top of mind. And then, of course, the increasing regulations that come as a result of that, right? Where we see gas owners and operators now with TSA, some of those requirements. We see EPA looking at water. We see new reporting requirements from CISA with CERCIA and SEC reporting requirements. All while there's a need to actually not slow down, but increase the pace of innovation, increase the pace of digitization, to support prosumers and bidirectional energy and DERs, and bring new applications and new digital services to the market as quickly as possible as a competitive advantage, right, in many cases. And then just to ensure compliance in a number of areas with that, and also improve that customer experience. So those are some of those drivers, and cloud certainly plays a part in enabling the speed and the agility to do those things. But then there's the big compliance question, and that's what we'll talk about today. So next slide. And then also, of course, we have events like Colonial Pipeline that really illustrate why it's not enough just to have that visibility across corporate and IT systems, but you also need to have end-to-end visibility across IT and OT environments, right? And in our space, you see a lot of new entrants that are cloud native. So there's some limiting factors in terms of how you architect and deploy a SIM, for example, to look across OT. When I first joined Splunk, we saw a lot of our customers using Splunk in an ad hoc manner to monitor their OT networks. And we put together some prescriptive content that aligns with MITRE ATT&CK for ICS and some best practices there. So for us, it's a unique thing that we have cloud coming up constantly in conversation. So how best to manage that, how to architect things. And I think the good news is for Splunk, at least, there's a lot of flexibility in terms of how you can deploy Splunk. And we'll talk about that here in the remainder of my time. So next slide. So specific to SIP, you could really have three separate conversations with regards to Splunk and SIP. The first and the most obvious one is, well, how can Splunk help you be compliant, right? So if you imagine we're gathering data from endpoint, from assets, from firewall and network, and alerts from IDS and other systems, and bringing all that into one place as a SIM, right? So there's the obvious areas where for perimeter, for SIP5, looking at things like firewall rule changes and prohibited traffic and failed logins. For SIP7, looking at endpoint and patching and system config changes. For incident response, for change management, for SIP8 and SIP10. There's plenty of ways that Splunk can directly be applied to help with SIP compliance. And then also more recently with SIP15 and INSM, looking at network anomaly detection and user behavior analytics. all areas where Splunk would, directly apply. But then that second conversation would be, well, how do you prove compliance? So we put together, a pretty comprehensive number of real-time scorecards and dashboards and reports that data is already in Splunk. It's just a matter of filtering that and formatting it now to help with audit and help with those compliance activities. So that's the second conversation. But then the third one, and where we'll spend the rest of our time today, is how do you deploy Splunk in a way that's compliant? And Splunk's a little interesting in that it can be in scope or out of scope. As a SIM, it's going to be commonly classified as an ECOMS. So, how do you actually prove compliance if you host that in the cloud, right? There's a number of challenges around that. But in other cases, we may just be dealing with BCSI, or just monitoring corporate and IT workloads, right? I'll say that the majority at this point, the majority of our utility customers are using Splunk Cloud for the majority of their data. That applies largely to corporate and IT workloads around security and around resilience for IT monitoring and infrastructure monitoring and observability for monitoring cloud and multi-cloud and those cloud native applications. But for OT environments, we'll see customers keeping a separate on-prem instance to meet their obligations there. So next slide. One thing I really want to make clear, though, because it did come up a couple of years ago, there's a meeting of CISOs from the largest IOUs that get together every quarter, and a rumor was circulated that Splunk is ending our on-prem solution. So I just want to be crystal clear that is not true. We are fully committed to a hybrid world and have no plans at all to end support for our on-prem solution. And we continue to release new features and capabilities and continue to support that. And in fact, we see that as a strength of ours, the flexibility of the ways that you can architect and deploy the Splunk platform. And here's just a pull quote from a blog post that came out of some of that from our chief product officer. But do just want to be clear that we're not ending on-prem. We see, because of not just utilities, but other industries as well, there's regulatory requirements. There's regional data requirements as well. So I think hybrid is here for quite some time. That said, we would love to see changes to CIP that is more permissive of cloud, and we'll talk about really why we think that's important. So next slide. So the customers that have moved to cloud, here are some of the drivers for them. Obviously, faster time to value, being able to deploy our platform in a matter of days and start getting data in, start searching that data, start delivering use cases for security and IT teams and DevOps teams quickly. That's obviously really critical, right? Reducing that time to value. But then also just the cost of infrastructure, the number of hours required to maintain that infrastructure, being able to eliminate that is very important as well. We see, higher level, more strategic priorities moving away from data centers into cloud. There's larger business cost savings to do that have a direct impact on some of these systems that our customers are relying on. And then really for Splunk specifically, being able to optimize the limited resources that teams have, right? We know that's a challenge within cyber specifically. Everywhere you look, being able to help those teams focus less on the administrative task, those low value tasks, and allow them to focus on more high value tasks for security specifically. And then of course for us, for our cloud platform, having kind of that foundation for compliance, things like SOC 2 Type 2 attestation and ISO 27001 certifications, FedRAMP moderate, IL5, and FedRAMP high now is in preview with a few of our customers. We're expecting that to be fully certified here sometime this month. But being able to have all those controls in place so that as CIP changes, we'll be able to leverage things like FedRAMP, like the government and DoD is already utilizing today. I suspect that any changes that are made are probably going to leverage best practices and those types of controls for the cloud environment. And then, of course, being able to scale quickly. I mean, that's the reason folks turn to the cloud, is being able to spin things up, iterate, innovate, all the benefits that come from that. Next slide. So just a couple of examples of what our customers are doing and the value they're seeing from cloud is, if you look at a typical deployment today on-prem, there's 12 admin tasks required to kind of part of the care and feeding of the Splunk platform. Well, when you move to cloud, you're able to offboard 8 of those directly to Splunk when you're doing that as a service, right? So a significant amount of time savings involved, and that's some of the value that cloud offers over, traditional on-prem solutions. And that's true not just for Splunk, for any number of tools out there. So that's why you see more and more companies moving to cloud and moving away from on-premise. Next slide. And just an illustration of that, we surveyed over 1,000 of our customers and found that, traditionally when they're just running on-prem, 40% of the time was involved with some of that platform management activity that you saw on the previous slide. And then on cloud, they've been able to reduce that 40% down to 5%. So a 35% time savings there. And really the most important takeaway from that is the pink piece. 20% is focused on delivering those use cases to security and IT teams. And now we're dealing with, over half of the time being able to deliver those use cases. So a lot of benefits that cloud offers there. Next slide. And then I think the other big thing that's a game changer, we see just an explosion of volumes of data, that data velocity. How do you manage that in a way that's cost effective? And instead of spinning up additional infrastructure that you have to manage and taking on that cost and the time that it takes to deploy that, because we know those hardware refresh cycles are not that frequent, especially looking at CapEx and those models. So how can you do that more cost effectively? And then more than that, if you look at the data, and we do think resilience is really a data problem ultimately, to understand threat, to understand where there might be performance reliability issues on your infrastructure and with IT, certain data has higher value than others, right? So that lower tier C data, you may not see enough value to justify building out that infrastructure or increasing a license on a data ingest basis. So with cloud, you have the ability to look at other subscription models, like compute-based models that you're actually paying based on how much you're searching data and not just how much data you're onboarding. So that frees you up to bring in that lower, kind of tier C, tier B data. And what we see more often than not, when folks bring that data in and start applying that in security scenarios and correlating all that data, it's actually a lot higher value than they may have first thought, right? They found a lot of things that may have fallen through the gaps otherwise. But that's another thing that cloud does as an enabler. Next slide. And one other piece I'll mention on that is being able to leverage credits from cloud providers. And I should have mentioned Splunk is available on AWS, on GCP. We're now in preview for Azure and expect that any day now to be GA. So a lot of different ways to deploy it. But like I mentioned, you can also deploy on-prem, and that's what customers focusing on things within the ESP are doing. And I mentioned that we're going to support it, but do know we are cloud first in terms of our innovation. So you'll see new capabilities pushed every 4 to 6 weeks versus on-prem may just see an update every year or maybe twice a year. So those are some things to keep in mind. And certainly cloud, the advantages of cloud are just the increased pace of innovation as well in terms of the capabilities that you're going to get, not just from Splunk, but from other vendors and solution providers as well. Next slide. So I mentioned there's a flexible number of ways to architect Splunk. We're certainly not going to get into a technical architecture. That's a very Splunk specific conversation. But I do want to stress that there's some very interesting things you can do in terms of searching between different instances. I mentioned our utility customers would have a cloud instance for corporate and IT, and for SIP regulated workloads, they would have an on-prem instance. But there's a lot of flexibility in terms of how you can search between instances. So between on-prem and on-prem, between cloud and cloud, cloud to on-prem, on-prem to cloud. There's a number of ways to architect that. And of course, we have encryption in transit and at rest available. And, really our vision for data management and the way we see the things evolving in the future is to take analytics to where the data lives. So today now you can search directly, do a federated search and federated analytics on S3 in AWS with Splunk, and expect to see more and more providers become available going forward, because really that's the direction that we see things headed. Next slide. Just the final piece to note, you see other utilities that are leveraging things like AWS private links. They may have their own unique requirements as well, and they want to prohibit any use of sending data directly over their internet. So you do have that additional layer to insulate that data via private channels with things like AWS Private Links. So lots of ways to structure things. We didn't get into kind of the shared model for what is the customer's responsibility in terms of architecting the data gathering. There's a number of ways to get that data into Splunk through forwarders, through agents, through APIs, database connections. So those are all things that we could have. Next slide. If there's interest in learning more, please reach me directly. On the next slide, you'll see my contact information here. So feel free to reach out to me. You can also find more on the web. If you just Google Splunk and Energy and Utilities, you'll find it there. We'll share this deck after the presentation. But yeah, I'll just leave it at that and hand back to you, Tim.
Thank you very much, Rustin. I appreciate it. And as mentioned, this slide deck, just like all of the other webinars in this 6-pack series, they are all available online. The recordings will be available. So you can watch the recording and see the slides fly by, or you can get the PDF and kind of go through them at will. Contact information here, and we will move to our next presenter, which is Robin. If you can unmute.
Thanks, Tim.
Well done. Let me get moving on to the next slide here for you, and I'll turn it over to you, sir.
Great, thank you. So, hi everyone. My name is Robin Butier. I'm the CEO and co-founder of Network Perception. My goal today is really to share our perspective as a small business that's not yet in the cloud, but considering cloud deployment in our roadmap based on requests from some of our customers. But yeah, for this webinar, we wanted to have a variety of viewpoints. So I'll share from the viewpoint of a small US-based company. Next slide. I'll start with a bit of context on what we do, why we're considering cloud, and then I'll spend some time on the pros and cons of such a decision in terms of when do we need to balance investment versus return on that investment to support our customers. So Network Perception is headquartered in Chicago. We have about 30 people, about 100 customers. We started as a prototype developed at the University of Illinois in Champaign-Urbana with funding from DOE and DHS, and quickly we specialized in supporting the needs of asset owners and asset operators, as well as auditors for NERC CIP, specifically CIP 3 and CIP 5. So everything around network segmentation and making sure that firewalls are correctly configured. Next slide. The technology works today completely on-prem. So again, nothing in the cloud as of today. We model networks based on config files that we ingest from firewalls, routers, and network switches. And from that network modeling, we produce a topology diagram, so a visual map of how the IoT network is configured, as well as a variety of reports around firewall rule sets, what rules are overly permissive, which configuration may have security risks or compliance risks. And then we also model all the paths inside those environments to check whether the segmentation has been correctly implemented. And so we serve the needs of mostly the security team and compliance team, but also the auditing team. Next slide. So a key feature that we have around this modeling capability is to compute and calculate all possible network paths in the network. So what you see on this screenshot here is an example network with a few firewalls. I think we have 8 firewalls, 4 different zones. So the untrusted zone at the top, the SCADA or trusted zone at the very bottom. So it's a typical Purdue model. And then we highlight in blue networks that are used as a source, and then in red, the one used as a destination. And so in this example, we have multiple source networks that can cross, you can see path highlighted, like they can cross firewalls and go all the way to that destination at the bottom of the screen. And it's a connection on TCP 443. So what we do is we we take each of those config files regardless of where they're coming from. So they could be Cisco, Palo Alto Network, Checkpoint, Fortinet. We model those and then we compute all the path. And that works really well for a few dozen of firewalls. But when we get to very large networks of hundreds or even thousands of network devices, then we are encountering a scalability challenge. Like, how do we compute all the possible paths end to end in this state space that could explode because of just the sheer size of the network? And really, that's been the driver for us to consider offering a higher computation capability with a cloud-based deployment. So we've been doing some research and looking at the areas of possibility, of course, by maintaining the requirement for complying with NERC CIP, because the primary industry we support is the electric utility industry. Next slide. So a driver to be able to do that large-scale computation with more horsepower, like more CPU, more memory through a cloud provider. The driver has been for us to find a solution where the BCSI data, so any confidential data that has to be labeled as BCSI by the asset owner, would stay local, meaning that we do the computation we need in the cloud, but there is no technical mean for us as a provider of a solution in the cloud or for the cloud provider itself to access any of that BCSI data. And the solution to do that is to leverage tokenization, meaning that there is an on-prem piece of software. Our product is called NPU, so they install that on-prem piece of software, and then we tokenize all the BCSI data, so IP addresses, object group names, anything that it's labeled as sensitive. And only the asset owner has the detokenization table on site. We can send the tokenized data in the cloud, do the computation at large scale, get results extremely fast, and then through a web UI with the detokenization table, have the true network map being displayed for end users without any risk of whether the cloud-based database could be compromised. There's no confidential data stored there at any time. So this is again, part of our roadmap. We haven't deployed that yet, but we're looking at what are the advantages and possible limitations of doing such a project for both us and the customers. So if you move to the next slide, Tim. So in terms of pros, we're looking at, as I said, scalability and flexibility, because with the cloud-based deployment, we're no longer limited by local resources. It's also much easier for us to push software updates, troubleshoot network modeling issues without having users to upgrade manually a piece of software on their side. Improving accessibility, because customers now can remotely access that database regardless of where they are, and it provides better backups, better disaster recovery solution. And then important competitive advantage, right? Because we can accelerate that developing the solution to innovate faster and make sure we serve our customers better. Next slide. So in terms of on the other side of the scale, we're of course considering the NERC CIP requirements, looking at how the requirements have changed this year for third-party providers with the cloud. How do we ensure that none of that BCSI makes its way to our cloud-based solution, and then being able to provide evidence of limiting access to any type of data that could be BCSI. What are the risks in terms of the CIP compliance for our customers to ensure that they have all the data they need for an audit? Operational risk. This new architecture that I described in the previous slide adds another component that depends on internet connectivity. So The all on-prem brings a new variable there that we need to take into account in terms of downtime, and then cost and resource implications. So for us to provide that infrastructure in the cloud, as well as the new OpEx that we have to take into account in our licensing structure for our customers. And the next slide. So to conclude, in terms of guiding principle, we've always, of course, want to keep an active dialogue with the community, and that's why we're part of the CTAG. We want to make sure we listen to our customers first. They're in the field. They have priorities and constraints that are pretty unique in terms of OT. So we want to make sure we align with those priorities, and any solution we provide is supporting them. Of course, always exploring a hybrid approach, as the previous presenter mentioned, developing software that are compatible for both on-prem and cloud deployment, and reassuring our customer base that we will never remove the on-prem part. And then what's important for us as well is for any solution we develop, to take the user experience into account in terms of the complete life cycle of our product, from the acquisition, the deployment, to putting it in production, as well as scaling it to a larger set of sites. So how does adding a cloud-based component enhance that user experience, or add some friction that would need to be taken into account before we push that to the marketplace? And with this, I'll hand the mic back to you, Tim.
Thank you very much, Robin. I appreciate it. And with that, if Thomas, you can turn on your video, and I will get us moving to your slides. And hopefully, if you can, I can't see you, but maybe others can.
Oh, can everybody see? I should be.
There you go. All good.
All right, welcome.
I'm gonna shut off, and you're good to go.
Awesome. Well, welcome again, everyone, to the third webinar from the Cloud Technology Advisory Group. Today, we'll be looking at cloud-ready technology and NERC CIP standards from the application provider's perspective. This presentation is provided by GE Vernova Electrification Software, and will focus on GridOS as a technology stack designed for regulated workloads. Hi, I'm Thomas Peterson with GE Vernova Electrification Software. I'm a principal product cybersecurity leader with the GridOS platform, focusing on cloud-ready GridOS-dependent applications such as distributed energy resource management, their associated systems, including aggregators, and artificial intelligence with machine learning. I'm currently working on a number of engagements regarding ADMS, AMS, and DERMS. Just a side note, when I mention GE Vernova in this presentation, I'm specifically referring to the electrification software business unit that deals with transmission and distribution control room software. For my portion of this webinar, we'll be addressing ways in which GE Vernova embraces our CIP regulated customers' primary concerns, and some of the ways we already support their compliance efforts, and how our roadmap intentionally meets the spirit and letter of CIP compliance. We'll also be talking about how GridOS enables dynamic responses to new services, such as DER resource demands at the edge through IT and on-prem OT. We will talk about how we support a path to cloud adoption and regulatory considerations for moving grid applications to the cloud. We will then look at how utilities can get their organization ready for cloud technology acceptance before wrapping up with our Q&A session. As some may know, GE Vernova Electrification Software manages over 30% of the world's power through generation, transmission, distribution, markets, and analytics. A good number of our customers are looking to GE Vernova to lead in areas of enabling cloud-ready technologies, products, and services. GE, and now GE Vernova, has a long history of a tight partnering approach to supplying the technology, tools, training, and services to support and grow the energy industry. Whether that is in the US with FERC and NERC and or regions beyond North America, our goal is to create a safe environment to deliver power. GE Vernova is hyper-focused on engaging with our industry customers and stakeholders to educate, inform, and shape our path forward. We regularly hold outreach and customer engagements to ensure alignment, and of course there is our international outreach called Orchestrate. These interactive activities provide listening and feedback sessions to ensure our direction and delivery exceed expectations and demonstrate a spirit of servant leadership necessary for our mutual success. So, next slide. So GE Vernova is actively engaged to provide support for critical infrastructure protection programs. Here are some of the ways GE Vernova supports both the spirit and letter of NERC CIP compliance regulations. CIP 4 often requires the processing of personally identifiable information to verify an individual's identity and conduct a background check. This type of PII data has become increasingly regulated under legislation such as the General Data Protection Regulation, GDPR for EU citizens, and the California Consumer Privacy Act, CCPA, with hefty penalties to failing to protect individual PII. GE Vernova personnel risk is transparently managed with our utility customers through our PRA portal. Regarding CIP 5, Grid OS is built for segregation of network security zones. GE Vernova software is flexible and dynamic in its support of tiered access, monitoring, and alerting. For CIP 13, communication links and CIP 12, CIP 12, communication links and sensitive bulk electric system data communication between control centers needs to be protected in a manner that is appropriately tailored to address risks posed to the bulk electric system due to the sensitivity of the data being communicated. GE Vernova supports multiple methods a utility can implement to meet the data in transit protection requirements, utilizing features and functions that are likely already present in the control system's operating environment. Now to CIP 13. GE Vernova electrification software's secure product delivery methodology is based on an industry-leading third-party platform which can be accessed using a variety of methods, facilitating ease of use based on a customer's use case, preference, and connectivity model. Utility personnel can choose to download software and updates interactively via website, a platform-independent command line interface, CLI, suitable for scripting, or by integrating with the organization's own repository management solution, or build tools for easy synchronization. Slide. Secure product development processes are covered by many external publications, including, but not limited to, the guidelines, standards, maturity models, and government regulations. Many of the requirements therein are duplicative, creating a web of overlapping practices that can therefore be considered industry standard practice. Therefore, GE Vernova has attempted to consolidate and unify these controls into a single unified controls and compliance framework for secure development based on IEC 62443-4-1 SDL for Industrial Automation and Control Systems, or IICS. Open source software security at GE Vernova is primarily focused on utilizing the Secure Supply Chain Consumption Framework, the S2C2F, originally developed by Microsoft to ensure OSS is managed appropriately. This starts with evaluating new OSS against criteria and control introduction into the approved repos. Then continuous monitoring and scanning of selected OSS for software health and security. Finally, providing the ability to notify specific product teams of the need to update their code and release of updated electrification software products through a secure customer portal. The secure software development cycle doesn't end even after our developers are done coding, testing is passed, and the software is packaged. At GE Vernova, it's not complete until the software is securely in the hands of our intended customers. For critical national infrastructure, this means only those authorized to access it from an authentic source without modification and ease of access despite a presumed air gap. So the next piece is CIP 15, internal network security monitoring, is one of the newest sets of CIP requirements that will be going into effect, requiring not just protection monitoring at the edge of the OT network, i.e. NERC electronic access point firewall, but within the OT network itself. This most likely requires an investment from the utility in the form of a network intrusion detection system, also known as a NIDS, hardware, and establishing a baseline of what normal network within OT looks like. To better support our customers, GE Vernova Grid OS uses industry standard protocols, avoiding proprietary protocols, and this in turn encourages utilities to implement INSM. So I want to highlight a little more in depth on how GE Vernova Grid OS addresses software and patches with authenticity and integrity from development through delivery. Continuous integration is the practice we run in GridOS, where we build the software such as adding new functions, features, microservices, or whole apps. As the software developers commit their code, our Artifactory is continuously building, testing, and running the software automatically. Continuous integration ensures that from day one, no commits break the software. There's always something to be run. As we build software, we build unit tests. So as the code base develops, more and more testing automatically happens after the build, including contract tests for the APIs. In our private Artifactory, we perform a lot of other best practices like code scanning, looking for weak or insecure code patterns, container scans, scanning all our software and all the dependencies in the container for CVEs. This is also where we can store software builds, containers, infrastructure as code, also known as IAC, YAML, and Helm. And it is here where the Artifactory can produce SBOMs associated with each container. Once a product matures, at the end of a continuous integration pipeline is a product reference environment, also known as a PRE, with a fully deployed set of microservices, including the IAC deployments and configuration YAMLs and Helm, running functional and end-to-end tests. All of these allow us to perform real tests with data, configurations, and deployments that match real systems. Once these tests pass, and of course, all the pipeline tests and scanning has been verified clean, we will create a release. These are locked containers, configuration, and infrastructure as code ready to be deployed. Moving to a continuous delivery system is where we add some more steps and where our customers get involved. We bring different GridOS products together and run them in solution reference environments, also known as SREs, for example, where we run different apps side by side in standard configurations and testing. We may also run project reference environments called PREs, or through an evergreen cloud environment, matching customer configurations. Releases will happen often. Currently in GridOS, we are internally releasing once a month, but it could be more frequently, continuously releasing production-ready artifacts. Because we manage breaking changes and use semantic versioning, so breaking changes can be easily identified, and because we test upgrades ourselves in our SRE and other environments, these releases are ready to be continuously deployed. Authenticated customers can access our Artifactory releases and pull them into their own pipelines. This may be just a quick run into a test or QA system to run their own scans as it progresses to production. The whole process makes getting continuous, secure, and validated updates easy, keeping real-time and critical infrastructure systems always up to date. So let's shift gears and engage on like complementary technologies with additive impact. Microservices and containers. Microservices can best be thought of as small collections of closely related processes that operate as a single independent service. Here we highlight a familiar application for transmission and remedial preventive action as an example of an architectural alternatives. As a monolith, the application as a whole must be scaled out to meet increasing requirements for the number of contingencies processed, resulting in excess capacity being allocated. It is also much more complex, and any change requires the entire app to be tested and replaced. Contrast this with the microservice approach, where each function is broken out into separate microservices that can be scaled out horizontally, including dynamically based on demand, and updated independently, optimizing capacity and simplifying the changes. As another example of the types of benefits attributed to microservices, consider a web store as an example. Different aspects of the store are used more frequently than others and by larger numbers of concurrent users. For example, a large population of users browse content. A subset of that population put items in the shopping carts. An even smaller subset of that population purchases items in their shopping carts. While the web store could be architected as a single colossal application, microservices provide a better and more granular approach. By breaking the application up into separate microservices, we could have thousands of instances of browsing services, hundreds of instances of a cart service, and only a few dozen instances of purchasing services, each capable of scaling dynamically based on actual demand, providing deterministic response while minimizing the required resources overall. Containers. Containers are There are different virtualized architectures solve different problems with different economic compliance and efficiency benefits. Where hardware virtualization introduces a hypervisor to virtualize the underlying hardware platform, containerization takes a different approach. A container runtime environment is used to virtualize the operating system. This result is the containers are lighter and smaller than VMs. They do not carry the guest operating system with them. They're also atomic in nature, carrying everything with them required to run the containerized services, making them highly portable. Containers are the key enabler for microservice-based architectures and the inherent modularity provided by GridOS. So, microservices and containers deliver different value than the technology stack they reside on, whether that is on-prem, hybrid, at the edge, or on cloud. Here is a good illustration of the shifts in value and opportunity between the two. While there can be mutually supporting value propositions, the goal is not one-to-one alignment, but finding the better balance and orchestrating applications and services closest to the need. Some may ask how utilities can lay the foundation for a successful journey to a cloud adoption. For GE Vernova, cloud is a technology, not a destination. Everything we build is based on best-of-breed cloud-native compute foundation CNCF components that are deployable on the data center or bare metal or VMs or on any of the public, private, hybrid cloud infrastructures available. We are not prescriptive as to where workloads should run. Rather, our goal is to provide flexibility to our customers. With that flexibility of deployment models, our priority is ensuring interoperability with utility existing control, compliance, and cyber systems. GridOS is properly positioned to dovetail into their existing policies, processes, and procedures with a bring your own cyber approach. This reduces the utility's burden to rewrite their plans, as is many of the same tools, techniques, and methods previously employed, just in another context. That context, should it include elements of cloud technology, encourages scaling up and down at the speed the utility can manage. So the next obvious question is, how do utilities prioritize grid applications for grid deployments and cloud deployments? For this, we recommend a framework based on certain attributes of grid applications, such as mission criticality, real-time nature, and the regulatory environment. The grid applications on the right of this framework, such as EMS and ADMS, are highly mission critical, real-time, and regulated. The grid applications on the left side of this framework, such as analytics, simulations, and the backup systems, etc., are less critical and less real-time and see fewer regulations. So the applications on the left are perfect candidates for early cloud adoption. Utilities can use this framework to set up cloud adoption roadmap, developing their staff and service offerings, and progressively move from the left to the right on their cloud adoption journey. GE Vernova's GridOS software portfolio offers both software product and deployment flexibility that balances utility requirements, compliance obligations, and cutting-edge technology. GE Vernova respects the compliance environments in which our many customers around the world operate, including NERC CIP, while providing the leadership, innovation, vision to support growth and sustainability. GE Vernova recognizes that not all utilities are ready for emerging technologies that will embrace zero trust and artificial intelligence. That's okay. We have created on-ramps to include strong authentication, enhanced authorization, and advanced logging with monitoring controls. For those wanting more engagement, machine learning and large language models for optimization and analytics, for those technology stacks that allow utilities to ease into and add those capabilities that are specific to their economic and efficiency goals. Grid software that works in any infrastructure environment is important for grid flexibility, speed, and scale. Grid applications of today and tomorrow need to be able to be deployed and scaled where the application is needed, whether on-prem, in the cloud, whether that's public or private, in the hybrid, multiple environments, or at the grid edge. This puts the journey to cloud front and center as utilities look to modernize grid operations. Utilities are looking to unlock flexible deployment models, which are critical to ensure grid applications and workloads are deployed where they are needed to support OT to IT to cloud to edge operations. GE Vernova respects and supports the goal of this tight integration to ensure end-to-end performance and deploy at scale where the application and workloads are needed the most. This can be closer to the analytics, compute, or geolocated for security and compliance. Thank you again for inviting GE Vernova and myself to engage in this important topic of providing our perspective on the why, where, and how we engage with our NERC CIP regulated customers on cloud. It is our privilege to meet and embrace them where they are at in their individual and collective technology journey.
Thank you very much, Thomas. I'm going to move us to just the last two slides, as I know time is running short, but that is something we absolutely expected with three wonderful presenters that we kind of allocated 20 minutes apiece. We would land the plane exactly when we were supposed to, but there are some things that I would like to cover. So first, I would like to highlight the other webcasts that have happened, as there is no way we could talk about all the various perspectives and interests as we talk about this topic of critical infrastructure protection and cloud services. It really is something that across these 6 webcasts, we're getting a feel for the various perspectives of people involved, from regulatory or regulated entities, asset owners and operators, to the application providers, to the cloud service providers, and kind of the consultants and contractors and system integrators and vendors who are working across many entities and seeing kind of the perspective from a variety of different places. And again, kind of looking at this from the perspective of, regardless of everything that we've talked about and what we've seen, no one is frozen in place. We are all, as entities, as an industry, as a cybersecurity and a electric community, we are all continuing to move forward. And some of the guidance and discussions we will have with some of the region representatives in regards to the steps being taken to help the industry move forward with more certainty. As we look to this webcast and what we've covered, I think I would highlight some of the things that I appreciated from the perspective of kind of stepping into the perspectives and sitting from the mindset of an application solution provider. Oftentimes when you think NERC and you think CIP, you immediately recognize that the asset owners and operators are the ones that are sitting across the table from the auditors. They are the ones that own the obligation for compliance, but they have partners and marriages with vendors and OEMs along the way, and how they do the act of compliance and kind of ensuring reliability across the system every step of the way. And so you naturally always think from the perspective of the asset owner and operator, but to hear from application solution providers and the considerations they're making from their business models, their software development, the drivers, the innovation, they're considering customer value and the consideration of the compliance constraints and what that means for different customers and different geographies subject to different compliance obligations. Some of the slides on the pros and cons of cloud integration from an application provider. Again, I've envisioned those, I've seen those, I've worked with entities as they're considering it from an asset owner perspective, but to look across at all their solution providers and consider they're looking at the same things from the perspectives of what they're developing and what their customers might need. And the path forward from a software development train or application stacks where we got to see kind of a cloud adoption roadmap and the various paths that you can consider there. But I think the most important thing, and again, this is a marriage from entities to their solution providers and their vendors and OEMs, is this very, very early from Splunk, hearing it again from Network Perception, hearing it again from GE Vernova. And I think everyone who's been involved in the CTAG from the solution provider has said repeatedly, they're not abandoning their customers. They are very much in this game and in this space, and from the perspective of understanding what the importance of reliability and the importance of the customers across the electric community and across North America, where there is this ongoing question and need for clarification. They're not going to abandon product lines and solutions that they currently use, and that commitment is there. As we all work through where the technology is going, and it may always be of interest for many, many years for companies to continue operating the way they are. This isn't something that's going to go away in the next year or 2 years or 6 years, even if it takes that long for the standards to be developed. Hearing across the perspectives of large entities, small entities, those that are focused on electric sector and those that are focused on all sectors, and customer sizes from large to small. It's been great to hear from all three of our presenters today. I would encourage you to look towards the 4th webinar on cloud services and SIP standards using from the cloud service provider perspective, as we continue to move down this path for the current compliance challenges. And when we close this and hear more from the region perspective. We are officially on time. However, I would like to ask if anyone is interested in responding to a question. I see some of our panelists have been responding to the Q&A as we go. I will ask an open question, and I will try to frame this from the perspective of there may not be an answer that can be provided today, simply because many of the presenters that we've heard from, they may still have a lot of customers who are in the space that are on-prem and happy and stay in that course. There's some intricacies and nuances of this question that pertain to standards changes that happened in January. And maybe the request for supporting audit data has not come yet from some of the customers. So I will ask the question, if anyone has some experience in the space and wishes to provide an answer, I welcome you to unmute your video and provide, but it is very, very possible that this event has not occurred yet. So the question being, any of the organizations, any of these solution providers that are on the phone with us or the call with us today, kind of had a customer that's gone through an audit, has gone through this process, and they've asked for, can you provide supporting or stacked evidence to help us demonstrate how we comply and how we've configured our systems and how we're using solutions for BCSI that is in the cloud. A number of things have changed in CIP 004 and CIP 011 on January 1st. And to help accommodate and help organizations move into this path, kind of recognizing the reality that this has occurred. And in many cases, the entity can provide evidence, but they could also support and stack that evidence from their provider. So if anyone who's with us today would like to add some comments to this, I open it to you.
Thanks, Tim. In our case, we haven't had that experience yet. We're fully on-prem. However, we've been complying with CIP 13 for quite a few years, providing, answering questionnaires around how we're doing access control internally, how we're keeping audit logs, how we're doing encryption of confidential data, how we're identifying confidential data. So I think when the time comes and we get this request, that will fall into our existing CIP 13 program to make sure that we provide those reports.
That's great.
Yeah,
Anybody else?
I'll add a little more on that end. With Splunk, it's a lot of times, more often than not, it's going to be on-prem solution, right? For BCSI though, you have options to deploy Splunk with your own license and your own private cloud. So obviously there's not anything we're going to be providing in terms of documentation or anything there. But when you're using our SaaS Splunk cloud solution, we have a customer trust team. And of course, we're relying on, the certs and attestations that we already have around SOC 2 and things like FedRAMP, a lot of those controls. But we also do provide the ability for customers to do different tiers of audits as well on their own. So there's a low, medium, and high tier. And we have a customer trust team that provides a portal with all kinds of documentation and feedback that's available through that. So beyond that, there's definitely some flexibility there to help in those scenarios.
I'll just chime in real quick. So GE Vernova, kind of as a stance, does not tag, identify any data within the customer network. That's up to the customer to define that data and for them to determine their protection schemas around that particular data. So to that end, we would rely either on a contract or some other engagement agreement before we would provide evidence for their compliance program, because the utility does retain all risk. All that evidence would be maintained by them, and any information classification would be assigned and managed by them as well.
Very well done. I would just like to say thank you again to all of our presenters. I appreciate the bravery of coming on and dealing with this topic that I know it can get touchy in regards to what customers are doing and solution providers. But again, just this is something that our community has done historically very, very well for decades. We continue to do so. So again, thank you all for contributing to the CTAG and to this webinar series, and appreciate it. Look forward to our next one. Thank you, everybody.
Thank you.
Thank you.